In this video, we're going to talk about residuals. So we're going to talk about what a residual is in regards to our statistical analysis. So first off, with a couple of definitions, we have a residual. The residual is the difference between the actual value and the predicted value. So those are two things we have to have in order to calculate or find out what a residual is. It's the vertical distance from the actual plotted point to the point on the best fit line. So if we're imagining our scatter plot, so we've plotted our points, now we've taken a straight edge and we've determined where we think that line best fits the data, and we drew that line. We're talking about the residual is how far those points are, the scatter plot points, are from that line that we have now drawn as our best fit line. So we're talking about that distance from the line up to the point or down to the point, depending on where that point lies in reference to the best fit line. You can think of the residual as how far the data falls from that best fit line. So kind of how far off is the data from the line. We have two keywords there, actual Y value. This comes from the table or from the scatter plot. So we are finding these values from the table of values, or we're taking the coordinate right from the scatter plot. The predicted value is coming from the equation for the line of best fit. So because we've been talking about linear fits of, or linear best fit lines, we're taking our y equals mx plus b equation, and we're using that to determine what that y value is by substituting in a value for x. How to calculate the residual. So to find the residual, as it stated, it's the difference between the actual y value and the predicted y value. So we will take the residual, to find the residual, we're going to take the actual value of y and subtract the predicted value of y. So again, reminding ourselves that this value is coming from the table, and we're going to subtract it by the value we get from the equation. If we talk a little bit more about residuals from a visual standpoint, on the left we have a scatter plot. We fit a blue line of best fit to that scatter plot. When we talk about a positive residual, so what we're looking at here is an example right here. So we have this data point, which is at 8, and we have the line of best fit, which at that same x value, call it 2, that point on the fit line, I'm going to draw it here in pink, is at 4. So the residual is telling us that the data point is 4 above the prediction of 4. So the prediction is 4. The actual data point was 8. So when we use our calculation, actual 8 minus predicted 4, we get a positive value of 4, which is why this number is 4. It's 4 above. The data point is 4 above the prediction. So what does a positive residual mean? It means that the actual is more than the predicted. You essentially did better than you predicted. So if you have a positive residual, you're doing better than predicted, or you're higher than you predicted. So in a sense, kind of counterintuitive, you underpredicted. A negative residual, for example, here we have a negative residual of -2. That's telling us that our actual data points that we have observed are 2 below the prediction value. The prediction value is 5, because that's where it falls right on that blue line. The actual was 3. So again, we're 2 below what's being predicted. Hence the -2 as the residual. So this means your actual is less than you predicted. Or if you think about it, you did worse than you predicted. Again, a little counterintuitive, but doing worse means you over predicted. All right, so what we're going to do is we're going to kind of put this kind of in a full example. So we talked about cereal boxes. So we're going to go ahead and continue looking at that cereal box example. So we have a line of fit that has this equation, y equals 2.3x minus 132. So this was predicting the net weight of cereal based on how much packaging cardboard was used. So this prediction equation is predicting the weight. All right, let's look at our first example. Finding a residual. What is the residual for a 34-inch squared package? All right, so the first thing we want is the actual value that comes right from the table. So I'm going to look at 34 inches squared, and the actual value that we observe with a 34-inch square or square inch package is 21. So that actual value is 21. The predicted value is going to come from our equation. So I'm going to go ahead. I'm going to take my 2.3 times my x. Now my x is my packaging, 34, minus 132, giving us a result of negative 53.8. Now to find our residual, we are going to take our actual data point and subtract our predicted data point. So our residual will be equal to our actual 21 minus our predicted negative 53.8. Subtracting a negative, plus plus. So our residual value is 74.8. And the unit on a residual is the same as the y. So the y was grams. So we're talking grams. So the residual is 74.8 grams. This means that our actual is above our predicted. Our actual is above our predicted, and it's above 74.8 grams. So the distance from our point to our prediction line is 74.8 grams above. What is the residual? I'm going to try to keep the table in here. What is the residual for a 325 square inch package? All right, so now I'm looking at 325 square inches. And that actual value is 567. So I'm going to put 567 is my actual. My predicted comes from my equation. 2.3 times 325 minus 132 is going to give me a predicted value of 615.5. So that's how much we predict that package to hold. Moving on to the residual, actual minus predicted. The actual was 567. Our predicted was 615.5, giving us a residual of negative 48.5. So our actual is below our predicted. And you can't see what I'm writing. Actual is below our predicted. And it's below by 48.5. So it's 48.5 grams. I should put a unit on there. Lower than we thought it would be. So we over predicted. All right, last piece is we're going to use just using a residual. So what if we know the residual in one of our other measurements? The residual for a box of cereal is 20 grams. If the predicted is 250 grams, what was the actual? So you can think about this logically, or we can kind of jump right to our residual equation. So if we know the residual is the actual minus the predicted, the residual we said was 20, the predicted was 250, and the actual we did not know. So if we go ahead and solve this, we get our actual is 270. Now, when I said think about it logically, if the residual was 20 grams, that means it was above the prediction by 20 grams. The actual was above the predicted by 20 grams. So if the predicted was 250, the actual was 270. But again, going back to the equation is never going to fail us. Number 4, the residual for a box of cereal is negative 12 grams. If the actual amount is 185, what was the predicted? So again, if you think residual is negative 12, that means that actual, how much it actually holds, was 12 below we predicted. So if the actual was 185, that means our predicted was 12 above that, 197. So we're going to prove that with our equation. Residual equals actual minus predicted. Negative 12 equals the actual amount, 185, minus the prediction. Subtract 185 gives us negative 197 equals negative p, and divide by negative 1. So p is equal to 197. Should probably put some grams on there. Same with our last answer, grams. Hope this helps understand kind of what the residual is, how to calculate it, and then how to interpret it or use it based on the value being positive or negative.